calculated the net output by taking a weighted sum of input and their weights, right? So it's equal to summation of wi xi, and there is also one bias is included. So bias is also one of the weight that is being added to the perceptron network. The perceptron is similar to the neural network architecture. The single layer perceptron, it's like a feed forward network. So it's a feed forward network based on a threshold transfer function. Okay, threshold transfer function means what? The output is equal to 1 when the summation of all the weights multiplied with the input is greater than theta. So if you set a particular threshold and वो threshold के greater जाता है, the net input or the net output calculated, if it is greater than threshold value, it will present the output y equals to 1. Then if it's less than theta, ठीक है, net is less than theta, then it will give the output as 0. So there is a threshold transfer function, means you need to set a particular threshold to उस हिसाब से वो either 1 or 0. So it's generally used for a classification problem. So SLP, single layer perceptron, is the simplest type of artificial neural network. It's a simplest type of artificial neural network and can only classify linearly separable classes. ओके, linearly separable हमने लास्ट टाइम देखा था, linearly and separable and linearly non separable. Linearly separable मतलब if you draw a line and if the points is up of the line or down of the line, so they are linearly separable. And when it is not linearly separable, ये वाला डायग्राम आपको याद होगा, आई विल जस्ट शो यू. हाँ, ये वाला डायग्राम, ठीक है. तो इट्स एसएलपी इज जनरली यूज्ड व्हेन योर प्रॉब्लम कैन क्लासिफाई द लीनियरली सेपरेबल, ठीक है. दैट इज n is not sold and s is sold. So when the problem is linearly separable, you can use a SLP architecture or SLP algorithm, सिंगल लेयर परसेप्ट्रॉन. ठीक है, नॉन लीनियरली मतलब आप यहाँ से कोई भी लाइन ड्रॉ करोगे तो you cannot classify whether this is male or this is female, like that. So it's about the threshold value. Okay, so so single layer perceptron is the simplest type of artificial neural network and can only classify linearly separable cases with the binary target either 0 or 1. ठीक है, so the target will output only 1 or 0. So 1 when it will be output if the net value of the output is greater than theta, and 0 otherwise. Okay, and ये it can only classify, ये underline करो, it can only classify linearly separable cases. Non linearly separable cases वो नहीं कर सकता है. ठीक है. Algorithm, so the algorithm of a single layer perceptron does not have a priori knowledge. ठीक है, अब इसका मतलब क्या है, सिंगल लेयर परसेप्ट्रॉन को पहले प्रायर नॉलेज नहीं है कि वेदर सपोज यू वांट टू क्लासिफाई द पर्टिकुलर इमेज गिवन एज एन इनपुट इज अ डॉग और कैट. सो ही डजंट नो कि whether that particular image is dog or cat. It is unlabeled data. Okay, it is not a labeled data set, it is unlabeled data. So it did not have a priorly knowledge. So the initial weights are assigned randomly. So you can see W1x1, W2x2 plus Wn sorry, is greater than theta. So initially what happens? They assign the weight randomly. हमने देखा था कल we have randomly assigned the weight through coding. जैसे टू इंटू रैंड एक फंक्शन है that will assign randomly numbers to that particular weight. Okay, so the initial weights are assigned randomly. So the SLP sums all the weighted input, and if the sum is above the threshold, then SLP is said to be activated. ठीक है, तो perceptron कब कब activate होगा? Whenever the weighted sum of the weights multiplied by the input is greater than theta, then the output is 1. Means you will activate that particular perceptron. And if it is less than that particular threshold value theta, then it is will be deactivated. So the input values are presented to the perceptron, and if the predicted output is same as the desired output, okay, so the performance is considered to be satisfactory and no changes to the weight are made. तो weights में कब changes होंगे? When the predicted output is not same as the desired output, then only you have to change the weight. Else if कि आपके जो predicted output है is same as the desired output, you do not need to change the weight. So if the output does not match the desired output, the weights needs to be changed to reduce the error. So the weights of perceptron, if you want to if the output does not match the desired output, the weight कैसे हम लोग adjust करेंगे? That is delta W. It's equals to zeta. Zeta is the learning rate, usually less than 1 into D. D is the predicted output and X is the input data. ठीक है, तो input data लगेगा, learning rate लगेगा, that is usually less than 1, and zeta and D is your predicted output. And so because SLP is a linear classifier, and if the cases are not linearly separable, now you can see this is the famous classification problem. ठीक है, इसमें you cannot classify. ठीक है, this is suppose 1 1 है, so 1 1 the output is 0. For x1 equals to 1, x2 equals to 1, output is equals to 0. And 0 1, ठीक है, यहाँ पे देखो 0 0 पे आउटपुट इज 0, एंड यहाँ पे 1 कब है? when it is either 0 1 or 1 0. ठीक है, so this is an XOR problem. You cannot separate. आप ऐसी लाइन ड्रॉ नहीं कर सकते हो जो, अगर मुझे सिर्फ ब्लू डॉट्स चाहिए तो आई कैन नॉट ड्रॉ लाइक दिस, क्योंकि उसमें रेड डॉट्स भी आ जाएंगे. इफ यू ड्रॉ सच लाइन लाइक दिस, then this dot will give an error. So this is the famous classification problem and XOR problem. So this can be successfully classified by the multi-layer perceptron. Okay, multi-layer perceptron can reduce this such type of classification problem of XOR data by using back propagation algorithm. So we'll see what is multi-layer perceptron. So this is a general diagram of a multi-layer perceptron. In this multi-layer perceptron में there is input layer, hidden layers and an output layer. So this is also a multi-layer feed-forward architecture. So this is an hidden layer, right? Okay. So hidden layer like this, one, two are the hidden layers. Now, why they are known as hidden layer? Because they are not in direct contact with the outside world. That's why it's a hidden layer. So they do the all the processing within itself, and they give their output to the output layer. Okay, so the multi-layer perceptron look like this. Now, multi-layer perceptron defines the most complicated architecture of artificial neural network. So it cannot be only जो यहाँ पे दिखा है only two hidden layer. It can have multiple hidden layer based on your or whatever application you need to design. Based on that, the hidden layers will be defined. तो इट इज नॉट जस्ट आपको ये सिंपल डायग्राम दिख रही होगी बट इट इज वेरी वेरी कॉम्प्लेक्स स्ट्रक्चर. Okay, so it is the most complicated architecture of artificial neural network. You can see like this. Now it is substantially formed from multiple layer of perceptron. जैसे हमने सिंगल लेयर ऑफ परसेप्ट्रॉन देखा वही सिंगल लेयर को मल्टीपल टाइम्स ऑफ मल्टीप्लाई करोगे दैट इज मल्टीपल लेयर्स ऑफ परसेप्ट्रॉन. Now it has three layers, that is including one layer, hidden layer, and if it has more than one hidden layer, it is called as deep neural network, right? So this I have already told. If it is more than one hidden layer, it is known as deep neural network, and MLP is a type of example of a feed-forward artificial neural network. And in this figure, the ith activation unit in the lth layer is denoted as AI of 1. Okay. Now what it is saying, this is number of layers L equals to 3. The output they have denoted by T. The hidden layer they have denoted by D. And M are the input layers. Okay. So W out is the weights and it connects the first non-biased neuron in the second layer, that is hidden layer of H, to the third unit. ये देखो, the first non-biased neuron. This is the first non-biased neuron, and in the second layer, it is connected to the third unit of the output layer. Okay. So this bias is connected to the second hidden layer and then it is connected to the third output layer. Mm. So the number of layers and the number of neurons are referred to as hyperparameters. So ये सारे parameters आपको adjust करने पड़ते हैं. So they are known as hyperparameter of a neural network and these needs to be tuned. Okay, the number of layers and number of neurons needs to be tuned to reduce the error. So the cross validation techniques must be used to find ideal values of this. Now, what is cross validation techniques? You can see in this vector form, this one, that A of in is an input. Okay, it will produce an output of x1 and xn. So this vectorized form, why it is known as cross validation, because आपको number of layers को भी validate करना पड़ेगा, number of neurons and weights को भी validate करना पड़ेगा. So if weights is adjusted, what happens to the neuron? If neurons are number of neurons are adjusted, what happens to the weights? So you need to cross validate this data. So the weight adjustment training is done via back propagation algorithm. ठीक है, तो back propagation algorithm is very important. हमको किस हिसाब से weights को adjust करना है by using the back propagation algorithm. So the deeper neural networks are better at processing the data. Deeper means what? Number of hidden layers you need to increase. And if you increase the number of hidden layers, the data processing will be better. And अगर आप deep neural network बनाते हो, the complexity increase will be more. But the problems that is being developed by using the perceptron can be vanished by using the deep neural network along with the gradient descent problem. So gradient descent problem will get reduced if you use a deep layer algorithm. Now, a gradient descent problem I'll teach you later. So there are different problem occurs, and you need to use the different error reducing technique. So gradient descent problem is one of the problem, and you need to reduce it. So these are some of the notation that has been used in your book, Shivanand book. So AI in refers to the ith value in the input layer. AIH refers to the ith unit in the hidden layer. AI out refers to the ith unit in the output layer. Okay. So AI in, H and out, AO of in is simply the bias unit. That is the zeroth unit and it's equal to 1. तो हम लोग हमेशा क्या करते हैं bias को equal to 1. Ideally it should be 1. So it will have the corresponding weight W0 and the weight coefficient from layer 1 to layer L plus 1 is represented as WKJ of L. यहाँ तक किसी को डाउट है मल्टी लेयर एंड सिंगल लेयर परसेप्ट्रॉन में?
No, ma'am.
No, everybody understood.
Yes,
Okay.
ma'am.
Okay. Now this एक और बात बतानी है. This type of multi-layer perceptron is also known as Madeline model also. ठीक है इसको हम लोग क्या बोलते हैं इसको we say as a Madeline model also. So ये Madeline architecture is same as this of multi-layer of perceptron. If in exam asked about that is explain multiple adaptive linear neurons or Madeline model, then you can explain multi-layer perceptron only. ठीक है कंफ्यूज मत होना अगर मैडेलाइन मॉडल या मैडेलाइन आर्किटेक्चर एक्सप्लेन करने के लिए बोलते हैं तो इट इज जस्ट अ मल्टी लेयर परसेप्ट्रॉन. So it's similar to the multi-layer perceptron. So it's which consists of n units of input layer, m units of Adeline layer. So perceptron is same as an Adeline layer and I units of Madeline layer. Adeline and Madeline होता है इसमें. ठीक है तो हम लोग आज बैक प्रोपोगेशन नेटवर्क हम लोग पढ़ते हैं. So, the back propagation algorithm is one of the most important development in the neural network. So, it was developed by Bryson, Verbus, and Lekun. And this network has to be means it has awakened the scientist and engineering development to the modeling and processing of numerous phenomena using the neural network. So, this learning algorithm is also applied to the multi-layer feed-forward network. So, जो XOR वाला problem आ रहा था in single layer, so it was reduced by using the back propagation network of multi-layer perceptron. Okay, so the network, this learning algorithm is a multi-layer feed-forward network. It's consisting of processing elements and with the continuous activation function. So processing element कौन से इसमें same multi-layer जैसे input layer, hidden layer and the output layer. And there is a feedback from the output layer to the hidden layer. So this you can see this red lines. ठीक है? If there is difference in output, difference in the predicted output and the desired output, if it is there, then it feedbacks to the hidden layer. ठीक है? So this input goes to the input from the output layer goes to the as an input to the hidden layer. So whatever the processing is done in this hidden layer, again, if there is a difference again in the desired output and the input output, then again it goes back to the second one of the hidden layer. ठीक है तो ऐसे करते करते इट गोज टू द इनपुट लेयर अगेन यहाँ पे फिर से वो प्रोसेसिंग होगी अगेन इट गोज इन द फीड फॉरवर्ड नेटवर्क ठीक है तो बैक प्रोपोगेशन एल्गोरिदम अगर आपके predicted output and difference output is not similar then it goes to the immediate before वाला hidden layer okay वहाँ पे कुछ प्रोसेसिंग
Ma'am,
होती है हाँ जी
ma'am, I had a doubt like when the number
हम्म
of hidden layers increase,
yes
in a way our accuracy is also better, no?
yes yes
But then for processing, will it not take time? Like the more number of layers, the more time
yes complexity
can
increases
it can act like a disadvantage to the network, no?
yes yes it is disadvantage बट हमारा एक्यूरेसी पॉइंट हम लोग सपोज इफ in last problem I have taken the 10,000 number of steps तो उसमें कैसे एक्यूरेसी इंक्रीज हो गई लेकिन वो प्रोसेसिंग कैसे फास्टर हो गया अगर आपका सीपीयू इज फास्टर रैम इज फास्टर तो वो प्रोसेसिंग फास्टर हो जाता है it's not like that कि at the cost of speed you will reduce the accuracy ठीक है हमको एक्यूरेसी चाहिए चाहिए ही चाहिए यू कैन नॉट से कि अगर वेदर इफ इट इज एन सपोज इट्स अ थ्रेशोल्ड बेस्ड प्रॉब्लम ठीक है आइदर इट इज वन और जीरो इसमें एक्यूरेसी कैसे 100% आनी चाहिए हम लोग ये नहीं बोल सकते कि मेल को उसने फीमेल कर दिया फीमेल को मेल कर दिया तो हमारा मोस्ट इम्पोर्टेंट फीचर कौन सा है टू डिटेक्ट कि वेदर इट इज मेल और फीमेल सो आई वांट दैट एक्यूरेसी अगर मुझे मेरे एप्लीकेशन में एक्यूरेसी इज मोस्ट इम्पोर्टेंट देन आई विल गो फॉर एक्यूरेसी तो स्पीड कम या ज्यादा होगी डजंट मैटर फॉर मी ठीक है तो इट्स बेस्ड ऑन द एप्लीकेशन अगर आपके एप्लीकेशन में एक्यूरेसी इज नॉट इम्पोर्टेंट यू वांट स्पीड कि मुझे स्पीडीली उसका डेटा जनरेट करना होगा या जनरेट करना चाहिए देन द नंबर ऑफ हिडन लेयर्स शुड बी रिड्यूस्ड ठीक है तो आप डिसाइड कर सकते हो कि मेरे इसमें हिडन लेयर सपोज 4 to 5 है दैट विल बी इनफ फॉर मी तो एक ट्रायल एंड एरर शुड बी यूज्ड यहाँ तक 70% एक्यूरेसी मिल गया इट्स ओके it's okay for me for this type of application but जहाँ पे accuracy is important suppose in case of aviation है in that case the accuracy should is important ठीक है एविएशन में क्या होता है द डेटा दैट इज बीन फेड टू द बेस स्टेशन तो वो क्या एक्यूरेट होना चाहिए नहीं तो प्लेन कहीं के कहीं उड़ जाएगा कहीं कहीं और चला जाएगा या कोई और कंट्री में चला जाएगा The data is important, accuracy important. It's not that speed is important. Now, can you suggest कहाँ पे speed important होनी चाहिए? Accuracy is not so much important. Can you suggest any application जहाँ पे speed matters? Yes, I think speed doesn't matter in most of the application. हमको accuracy ही ज़्यादा चाहिए. Accuracy नहीं होगा तो वो application की importance कम हो जाती है. ठीक है. इफ देर इज एन एप्लीकेशन ऑफ सेम थिंग कि अगर मैंने दो तीन हिडन लेयर्स लगाए एंड एक्यूरेसी 70%, इफ आई इंक्रीज द हिडन लेयर द एक्यूरेसी इज समवॉट 90%. तो जो भी इंडिविजुअल पर्सन है तो वो एक्यूरेसी देखेगा या स्पीड देखेगा? इट विल ऑब्वियसली सी द एक्यूरेसी.
Yes, ma'am. Accuracy will matter.
यस. सो इट डजेंट मैटर कि आपकी स्पीड थोड़ी कम या ज्यादा, यू कैन वेट फॉर दैट मच टाइम, बट आई थिंक एक्यूरेसी, क्योंकि अभी बहुत सारे रिसर्चर्स आर गोइंग फॉर दैट एक्यूरेसी. इफ for that application is accuracy 70%, to how to increase that accuracy the researchers are finding out. ठीक है. So it's not only by increasing the number of hidden layers. You can adjust the weight, you can adjust the particular parameter. जैसे एक particular image है, image की pixel quality पे depend होता है. Suppose there is a blur image है, तो आप hidden layer को increase करने की वजह you can increase the quality of input image. तो उससे आपकी accuracy ज्यादा आएगी. ठीक है. सिर्फ हिडन लेयर को इंक्रीज करके नहीं होगा. इट डजंट मैटर हिडन लेयर आपकी कम या ज्यादा होगी, बट द फीचर्स दैट इनपुट्स ऑफ दैट पर्टिकुलर फीचर, वेट्स ऑफ दैट पर्टिकुलर फीचर, पैरामीटर्स जो होते हैं, तो ऑल दोस थिंग्स आल्सो मैटर्स टू गिव एन एक्यूरेसी. ठीक है. आर्किटेक्चर आल्सो मैटर्स. अगर आपने सिंगल लेयर यूज किया, उसकी एक्यूरेसी विद द एक्यूरेसी ऑफ मल्टी लेयर परसेप्ट्रॉन अगर आप कंपेयर करोगे, मल्टी लेयर की ज्यादा होगी, बिकॉज आपने एक और हिडन लेयर इनपुट कर लिया है, विच ऑलमोस्ट प्रोसेस बाय इटसेल्फ. वो अपने आप इनपुट कैलकुलेट करेगा एंड इट विल स्टोर दैट डेटा विद इन दैट पर्टिकुलर नोड. So सो इट्स अ गुड डाउट यू आर हैविंग कि अगर मैं इंक्रीज करती हूँ हिडन लेयर द कॉम्प्लेक्सिटी विल इंक्रीज, बट हम लोग एट द कॉस्ट ऑफ कॉम्प्लेक्सिटी विल गो फॉर एक्यूरेसी. ओके. So the back propagation algorithm is generally been developed to increase the accuracy of the network. ठीक है. If there is a difference in the output between the desired output and the predicted output. So ये predicted output कब मिलेगा? When you give suppose my desired output is cat and you give कैट वाला इमेज. ठीक है. एक कैट वाला इमेज है बट इट इज अनलेबल्ड, ये नेटवर्क को नहीं पता है कि वो कैट है. तो बेस्ड ऑन इट्स इनपुट फीचर, ठीक है, उसके फीचर क्या क्या है, सपोज इट हैज समवॉट शेप ऑफ अ कैट, उसको पता है कि शेप ऑफ अ कैट इज समवॉट लॉन्ग, आईज एंड उसके ईयर्स कैसे होते हैं, ये फीचर्स नेटवर्क को पता है. एंड इट विल थ्रेशोल्ड दैट पर्टिकुलर टाइप. डॉग का थोड़े अलग फीचर्स होते हैं एंड कैट के अलग फीचर्स होते हैं. तो इट विल लर्न बाय इटसेल्फ कि आप क्या कर सकते हो, इसके इटरेशंस बढ़ा सकते हो. इट विल लर्न बाय इटसेल्फ कि वो कैट का फीचर है या डॉग का फीचर है. तो वो सिमिलर इमेज को एक थ्रेशोल्ड में डाल देगा एंड अदर जो सिमिलर फीचर्स है वो एक थ्रेशोल्ड में चला जाएगा. सो इट विल जनरेट अ लीनियरली सेपरेबल डेटा. सो देयर मे बी एरर बिकॉज ऑफ error किससे होते, the noise introduced in the image, or you can see gradient descent problem is also there. So these all error will also reduce the accuracy. So whenever the predicted output is not equal to the desired output, then it will वो जो भी आउटपुट आया वो एरर इज गिवन बैक टू द हिडन लेयर, एंड हिडन लेयर फिर से क्या करेगा, वो इनपुट फीचर्स एंड द आउटपुट वॉट एवर द आउटपुट इज टेकन, इट विल प्रोसेस द डेटा कि हाँ ये आउटपुट गलत आया था. नाउ इट विल लर्न थ्रू इटसेल्फ कि ऐसे ऐसे होना चाहिए, ये इनपुट फीचर मुझे पते थे, एंड मैंने आउटपुट क्या दिया है. तो इट लर्न्स बाय इटसेल्फ, उसके एक्सपीरियंसेस इट विल लर्न. So the back propagation algorithm is important. So the for the particular given set of input and output pair, the algorithm will provide a procedure for changing the weights. So in this back propagation neural network, it is generally used to classify the input pattern correctly. So the basic concept of weight update algorithm is simply the gradient descent method, as in case of simple perceptron network हमने देखा था. So all these things are similar जो हमने error updation rule और weight updation rule हमने जो देखे थे, that is similar to the simple layer perceptron only. Okay, so the aim of this such a type of neural network is to train the network to achieve the net output, so that its ability to give the reasonable responses will increase, and so that you get a desired output. जो हमारा predicted output है should be equal to the desired output. ठीक है. So the training of back propagation network is done in three stages: the feed forward of the input training pattern, the calculation, and the back propagation of error and updation of weight. The testing of back propagation network involves the computation of feed forward phase only. ठीक है, अगर मुझे टेस्टिंग डेटा देना है, एक क्या होता है, एक ट्रेनिंग डेटा सेट होता है, एक टेस्टिंग डेटा सेट होता है. सो इट्स जनरली 80 and 20% होता है. सो 80% हम लोग ट्रेन करने के लिए डेटा भेजते हैं. ये मैं जो डेटा डेटा बोल रही हूँ, इट कैन बी इमेज, इट कैन बी स्पीच, इट कैन बी any data, it can be numbers. So you have to decide कि मुझे ट्रेनिंग के लिए कितना डेटा भेजना है एंड टेस्टिंग के लिए कितना डेटा भेजना है. सो इट कैन बी 80-20% या 70-30%. सो ट्रेनिंग के लिए ज्यादा, एज इफ द डेटा सेट फॉर ट्रेनिंग इज मोर, देन योर एक्यूरेसी विल इंक्रीज. ठीक है, आप ये रिवर्स नहीं कर सकते हो कि आप टेस्टिंग के लिए 80% भेज रहे हो एंड ट्रेनिंग के लिए 20%. सो दिस विल रिड्यूस द एरर. तो इट्स जनरली 80-20 ही रखते हैं हम लोग, या 75 लाइक दिस. बट इट्स लाइक 80-20% only. 80% data is used for training purpose. वो उसके features, whatever features that particular data is having, it will bifurcate, it will learn through that experiences, and 20% data is used for testing. ठीक है, it is unlabeled data. वो उसको network को नहीं पता कि what data is coming. It's based on the feature whatever network has learned through the experiences. It will calculate that particular data, and वो testing से वो compare करेगा कि जो trained data है and testing data are similar or not. So there can be more than one hidden layer. So if it is more than one hidden layer, it is beneficial. But in some cases, one hidden layer is also sufficient. So even though the training is very slow, once the network is trained, it can produce the output very rapidly. ठीक है, तो ये ध्यान में रखना, ये अंडरलाइन करो कि if even though the training data set you are having is very uh, very large training data set you are feeding, then what happened during that phase, the processing is very slow. But once it has learned or it has trained the network, तो आप कितने भी कोई भी डेटा सेट उसको दोगे, the output is very rapidly. First time it will be slow because वो क्या कर रहा है, वो ट्रेन कर रहा है, वो लर्न कर रहा है कि क्या क्या फीचर होने चाहिए. एंड आफ्टर दैट, अगर आपको ये एक बार एल्गोरिदम समझ में आया तो आप क्या करोगे, yes, if I feed this data, the output should be like this. So the output it can produce very rapidly. So a back propagation neural network is a multi-layer feed forward neural network consisting of input layer, hidden layer and the output layer. So the neuron present in the hidden and output layer have biases. Okay, bias should be added, and which are the connection from the units whose activation is always 1. So which are the connection from the units whose activation is always 1. So bias terms also act as a weight. ठीक है, तो आपको क्या करना है, अगर एरर आता है तो वेट्स को एडजस्ट कर सकते हो और बायस को भी एडजस्ट कर सकते हो. And this bias whose activation is always 1. So during the backpropagation phase of learning, signals are sent in the reverse direction. ठीक है, अगर मैं बीच में बैक प्रोपगेशन एल्गोरिदम लगाती हूँ, the signals are sent in the reverse direction to the hidden layer, and the input sent to the back propagation algorithm can be obtained from either a binary 0 1 or bipolar -1 +1. So you can apply this activation function, binary activation function लगा सकते हो या bipolar लगा सकते हो. So the activation function could be any function which increases monotonically and is also differentiable. And the activation function that you can use, it can be a sigmoid, it can be binary, bipolar. Okay. Hmm. So this was for back propagation. इसमें किसी को डाउट है? बैक propagation algorithm में डाउट है?
No, ma'am.
So why we need a back propagation? कौन बताएगा?
To increase the accuracy.
To increase the accuracy. And how it increases the accuracy? How it increases the
And it
accuracy?
will continuously update the weight of the node when it's coming towards the output.
Yes. Yes, when the output gives an error. What is an error? The predicted output is not equal to the desired output. This is the error. So there is the difference between the predicted and desired output. So this difference is given to the as an input to the hidden layer. So likewise, this is known as back propagation. So what is the need for a back propagation? It is fast, simple, and easy to program, and it has no parameter to tune. It is, I think it's flexible method. So there is no required of priori knowledge. कि मैंने पहले ही बताया, there is no requirement of a priori knowledge. Sorry. It is the standard method that generally works well with almost algorithm. Okay. I'll take your attendance. इसमें किसी को doubt है, then next time we'll see the gradient descent algorithm and some error error functions, that is mean square error, sum square error. Okay, so gradient descent and some error functions we'll see, and after that some numericals based on this chapter we'll see. Okay, give your attendance 24. Roll number 1, 2, 3,
Yes, ma'am.
4,
Present, ma'am.
5,
Yes, ma'am.
6, 6,
Ma'am, two present.
2. कितने दिनों बाद
Ma'am,
आए
roll
हो
number
कल?
two.
कहाँ गए थे?
मैम यहीं पे था. मैम
यहीं पे
माई
था,
माइक ऑफ था बट.
लेकिन तुम्हारी ये फर्स्ट क्लास है.
यस मैम, पता है.
क्यों? अभी तक 7 लेक्चर